Alright, let's look at an example of a logistic equation. Alright, the differential equation is dx over dt is equal to x times 1 minus x. And the initial value is x of 0 is equal to 2. Right? So since this is a separable equation, I'm going to go ahead and divide through by x times 1 minus x. Right? So you're going to get 1 over x times 1 minus x dx over dt, and is equal to just going to be 1 here. Alright, then I'm going to go ahead and take the antiderivative with respect to t. So here, same thing on this side. Alright, so we can cancel dt up here and dt down here. Alright, so I'm going to find the partial fractions here. So you have integral. Alright, partial fraction is going to be, I'm going to skip the steps, but this is actually simple enough to kind of guess. 1 over x plus 1 over 1 minus x. Alright, this is with respect to x. And the antiderivative 1 is going to be t. Alright, then plus some constant. I'm going to call it this constant c1. Alright, I want to save c for later. Alright, then I'm going to do a little bit of tweaking. Before we take the antiderivative, since derivative of 1 minus x with respect to x would be negative 1, I would like to have a negative 1 on top. So I'm going to scratch that and turn it into a negative sign. So it's still the double negative, it's positive, right? So if you find the antiderivative, you're going to get natural log of absolute value of x minus natural log of absolute value of 1 minus x. Alright, so this is still going to be the same thing as t plus c1. Alright, then I'm going to use the log property to write these two log expression as a single log. So you have a log. Alright, so subtraction outside is a division, so we're going to get the x over 1 minus x. Alright, so this is going to be equal to t plus some constant c1. Alright, so we can get rid of natural log by raising e to both sides of the equation. Right, so that way we can cancel natural log and e here. And right hand side, I'm going to write e to the c1 first. So e to the c1. And then I'm going to put e to the t here. Alright, and also I would like to get rid of the absolute value sign. So by scratching absolute value sign off, we have to consider a positive version and a negative version. Right, but here there's a big constant here. So instead of using a complicated expression, I'm going to call this whole thing just c. Alright, so what you get is this. Alright, we have x over 1 minus x, right, is equal to c e to the t. Alright, from here I'm going to actually go ahead and use the initial value condition here. So I'm going to plug in t equals 0, right? So x of 0 is 2 from the initial value condition, and minus 1 minus 2. And this is equal to e to the 0 is 1, so this is going to be c, which is, let's see, 2 over negative 1, so it's going to be just a negative 2. Alright, so we found c to be negative 2. So we have this equation. So we have x over x minus 1 minus x is equal to actually negative 2 e to the t. All right, so let's solve for x from here. So I'm going to actually come up here, and so that we have more room. So I'm going to go, I'm going to go up here. So go up here. All right, so I'm going to multiply both sides by the denominator, which is 1 minus x. Oops. Let's see, 1 minus x. All right, so we're going to have x is equal to, all right, so 1 times negative 2 e to the t would be negative 2 e to the t. All right, negative x times negative 2, so it's going to be double negative, so it's a positive 2 e to the t x. All right, so let's see, at t x. All right, so I'm going to add, or actually I should say subtract 2 e to the t x. So we're going to have 1 minus 2 e to the t x is equal to negative 2 e to the t. All right, then we're going to have divide through by quantity 1 minus 2 e to the t. So we get the x is equal to negative 2 e to the t over 1 minus 2 e to the t. Alright, if you want to make it look a little bit better, we can maybe multiply top and bottom by e to the negative t. And, whoops, sorry about that. And you have e to the negative t, right? Then we end up getting, negative 2 over, so you have e to the negative t. And here cancel out, so it's a minus 2. Alright, if you want, I don't like to have a lot of negative signs, so I'm going to actually multiply top by negative 1 and bottom by negative 1, so that we're going to get just a positive 2 over, negative 2 becomes positive 2, positive e to the negative t becomes negative e to the negative t. Right, so therefore we just found x of t, which is equal to 2 over 2 minus e to the negative t. Right, so that's the solution of the initial value problem. Right, that's it. I hope that this was clear.